Hello everyone, my name is Mahidom and we are Group LE4. And today we are proud to present our capstone project, the Automated AI Interviewer System. In this presentation, we will walk you through the full life cycle of our system, focusing on the cloud network architecture, the data transmission pipeline, and the AI integration. Now let's start with the context. In modern recruitment, companies face a bottleneck. Traditional interviewing is time-consuming, expensive, and subjective. To address this, our system targets three core objectives. One is data reliability, to capture high-quality video evidence via web browser. 2, efficiency, to automate the initial screening using AI. And 3, transparency, to provide objective data-driven and grading. Now let's move on to part 2, system architecture. To achieve this, we design a 3-tier architecture deployed on Railway, a platform as a service provider. We choose Railway for 2 critical networking reasons. One, it provides automated HTTPS and SSL certificates, which are mandatory for accessing the user's camera and microphone securely. And 2, it provides Docker containerization, ensuring our Python environment is consistent across deployments. Now let's see the architecture consists of. The first one is Tier 1 client layer, the browser-based interface. The second one is Tier 2 application layer, built with Fast API. It acts as the central orchestrator. And the final one is Tier 3 service layer, the Google Gemini API for multimodal processing. Now I will pass to Datina to explain the data acquisition pipeline.
Thank you, and let's dive into the technical implementation of data acquisitions. A major challenge in web-based recording is ensuring reliable transmission, and you can see in the code snippet. First, we implement client-side temporal tracking. We capture the start time using date now and calculate the precise delta when recording stop. Second, for transmission, we use the multi-part form data MIME type. This is crucial for network efficiency because it's allowed to encapsulate the binary video blob and the text metadata duration into a single HTTP post request. Here's the user interface. It guides the user from identity verification check-in to live recording phase, providing visual feedback throughout the process. Once the request hits our server, how do we handle large video files efficiently? We use an asynchronous stream ingestion strategy. Instead of loading the entire video into the ROM, which causes memory overflow, we stream the bytes directly into the Railway persistent volume using short-tail copy file object. Crucially, we implement a physical guardrail. Before processing, we validate the duration parameter. If the video is under 5 seconds, we immediately halt the process and we return a fail stated instantly. This optimizes cost by preventing valid API codes from being wasted on invalid answer. Next,
Well, once the data is securely persisted, the AI pipeline begins. Step 1 is the multimodal ingestions. Unlike traditional pipelines that require extracting audio tracks using FMPEG, we leverage Gemini's multimodal capability. We upload the raw video file directly to Google Cloud. A key technical detail here is the polling mechanism. The backend enters a loop waiting for the Google file status to switch from processing to active before triggering the transcription. Security is also paramount. Since we transmit candidate data to an external cloud, we enforce a strict cleanup policies. The first step is upload, then transcribe verbatim, and finally delete immediately. These steps are described as you can see in the slide. Step 2 is automated grading. Using the transcript generated in Step 1, we employ a persona-based prompting strategy. We instruct the large language model to act as a professional recruiter and evaluate the answer based on specific criteria. For example, introduction structure, logic, fluencies. Most importantly, we enforce a strict Zation output schema. The AI must return a structured Zation object with a numerical score and a text comment. This ensures our Python backend can programmatically parse the result. The final result, including transcript, score, comment, is serialized into a Zation file. For example, candidate A question1.Zation. This persistent file serves as the data source for the examiner portal described in the next slide. Serves as the data source for the examiner portal described in the next slide.
Finally, we close the loop with the examiner portal. To manage the data flow effectively, we expose two critical APIs. First, the dashboard APIs, /API/videos. This endpoint returns a real-time snapshot of all video files and their processing status. From a networking perspective, we use a HTTP short polling pattern here. Every 5 seconds, the client calls this API to refresh the table view without reloading the page. This keeps the architecture stateless and scalable. Second, the progress API /API/result/ceiling. This tracks the completion status for a specific candidate. It calculates the final average score only when enough data is available. Beyond monitoring, we implement powerful interactive controls for the administrator. What mode allows verification? The examiner can compare the AI score against the actual video and the full transcript side by side. Reject a fault-tolerant mechanism. If a file failed due to a network glitch, we can manually re-invoke the background AI task without asking the candidate to re-record. Hard delete /API/video. This performs a hard delete operation, removing the both web video file and the JSON metadata file from the disk to free up storage space. Finally, report generation. We implement an aggregation logic at /API/report. It consolidates all file individualization results into a single report static file. Logic check. The import is only allowed for the candidate has completed all 5 out of 5 questions. To summarize, Elite 4 has successfully delivered an end-to-end automated interview system featuring reliable data transmission using UTPath from data and streaming I/O, cost-effective processing with heuristic validation, objective branding using multimodal AI integration. Future work. To make this production ready, we plan to implement non-verbal analysis using computer vision, database integration for enterprise scalability, authentication for secure access.
I'm a second year in National Economics University in data science majors. Okay, tiếp nha. 3. What my greatest strength in English? My greatest strength is that my greatest strength is my deep technical expertise in data analysis. In my previous role, this allowed me to lead in the migration of our monolithic application to a microservice architecture, resulting in a 30% improvement in deployment frequency. And about my weaknesses, I would say on error, I'm actively working on this derivation. The problem is, in the past, especially when I was passionate about a project, I found myself trying to handle too many technical details personally, rather than fully trusting and utilizing my team members. This sometimes rồi ok quen.
Here's our examiner portal. As you can see, here's the AI analysis of the candidate answer, and we can get full report of the candidate by file txt. Here's the full report you can see of from question 1 to question 5, and AI analysis will automatically mark candidate answers and give us the transcript below, and we can rewatch the candidate answer, and we can also recheck it. We can clear data and I automatically refresh after every 5 seconds to get new answer from new candidate. Okay, and that's all of our web function.
This is the end of our presentation. Thank you for listening.